Hello everyone, welcome back to another episode of Solving LEETCODE questions. Today we're looking at first missing positive. The question is that given an unsorted integer array numbers, return the smallest positive integer that is not present in numbers. So for example, given the array 1, 2, 0, the output is 3. And given the array 3, 4, -1, and 1, the output is 2, since 2 is the smallest positive integer that is not present in this array. You must solve this question in O(n) time and O(1) space. Pause the video here if you like to think independently first. In these types of questions, it's always easier to start with the brute force method. My first idea is to sort the array first. This will take longer than O(n) time, but it's a good starting point. So for example, the sorted array in the first example would be 0, 1, 2. We can now traverse through the array, skipping through the non-positive numbers and incrementing our target whenever the number is already seen in the array. So for example, we'll increment the target when we see the 1 and increment it again when we see 2, and in the end return 3. Similarly, with the second example, the sorted array will be -1, 1, 3, and 4. So now let's repeat the same logic. We'll skip the number -1, starting with 1, incrementing target to 2, and when we get to 3, since 3 is greater than 2, we can now return 2 as the result. Now let's think about how to optimize this. We can make a few observations here. Observation 1 is that all the non-positive or duplicate numbers do not matter. Observation 2, the output will range from 1 to n+1. This is because with n numbers in the array, the missing positive will either be within n or is n+1. With this, we can draw the conclusion that we don't need to sort the entire array. We just need to try our best to put the numbers in their respective assigned index position. That way, if at a certain position, the value does not match its index, we know that this number is missing from the array. Now, let's go over the examples again. The idea is to put 1 in the first position of the array, put 2 in the second position of the array, and we don't care about the non-positive integers. So the resulting array from this first example is 1, 2, 0. By traversing through the array, we'll see that 1 is present in the first position, 2 is present in the second position. However, 3 is missing from the third position of the array, so the output should be 3. Similarly, for the second example, we'll put 1 in the first position of the array, put 3 in the third position, and put 4 in the fourth position, and fill in the rest of the values, which is -1. Now we traverse through the array, and when we get to the second position, we'll see that 2 is missing, so we return 2 as the output. Now let's transform this into Python code. The first step is to rearrange the array. Remember, we only do this for numbers that are non-positive and smaller or equal to n. And we'll swap the array such that the value at the index matches the index. Then after numbers have been rearranged, we can traverse through the array again to find the missing integer. We'll return i+1 when we see the first spot that does not match its index. Note the subtle nuance in i+1 here, since in most languages, index starts at 0. It's always safer to use an example to validate the exact placement. In the end, if all the numbers are in the right position, return n+1. This solution will satisfy the requirement of O(n) time and O(1) space. That's it for now. Let me know if you have any questions and what questions you want to see next.